5.3 partial fraction decomposition is not part of the content or curriculum, but it's definitely worth discussing briefly for those who are moving on. So basically, if you have a fraction, so the idea is this. I'll just come down here. If you have 2/3 plus, I don't know, 4/5, and you start on the right hand side, that would be 10 plus 12 over 15 multiplied by 5 multiplied by 3. So if you had that to start with, that would be what, 22, so 22/15. Well, you'd know that's 22, and then 15 can be factored to 3 times 5. So that's like the factors we have up there. So 2x plus 3 and the x minus 2. So you should be able to go backwards like that, or vice versa. You should be able to convert back and forth. So that's what the A and B represent up there. So we're not going to, let me erase that. Spend a lot of time on this, but basically what you do is you set up each factor, the 2x plus 3 and the x minus 2, there and there. And for each linear factor, you put an a and a b. You put separate constants of what they would be. Then you multiply both sides by the LCD, and you get the next line. So you get this. And there's a couple ways of doing this. One is to set up a system of equations. So you continue to solve. You can check that out if you'd like. And then you equate coefficients. So the coefficient of the x is 4. And as I collected here, the coefficient of the x is a plus 2b. Similarly, the constant is negative 2a plus 3b, and the constant is negative 15. So you set those equal, and what you have is a system of equations, 2 equations, 2 unknowns, and then you can solve that. Another way of doing that is to, way back here, choose values for x to eliminate a term. So if you choose x to be 2, then this whole thing is gone. And then you solve for b. And then if you choose x to be negative 3/2, then that whole term is gone and you solve. So that's doesn't always work, but that's a nice case to do. Decomposing, breaking up the rational expression into 2 different terms that are simpler is something you want to do if you're in different cases when you move on. So if you are moving on to calculus, make sure you study this a little bit. Okay, let's go on to 5.4, which is definitely on the curriculum. 5.4 is on systems of nonlinear equations in 2 variables. So what we mean are basically not lines. And so you have like circles, parabolas. You could have a circle and a line, or a parabola and a circle, or and then we'll later get into conic sections, which is done in a little bit. So what you have, let's suppose you have a parabola like this, and there's an equation that represents that, right? It's the quadratic form, right? So you have some equation. And then if you have a line, how many different possibilities do you have? Well, you could have a line like this that just totally misses. And so for that system, how many solutions would you have? There'd be no solution. Then you could have a parabola like this, and a line that just comes and touches in one spot. Just like that. I can actually move this around and make it touch in one spot. So you could have that case where it just touches. It's called a tangent line. So if it's tangent line like that, then there'll be one solution to this system. And then the last case, you have a parabola. And you have a line that, of course, just crosses in two spots like that. So if you have a parabola like that and a line, then you might have two solutions to the system. Then you could look at maybe a circle and so suppose you had a circle and a parabola. Let's copy that. So you have a circle and a parabola. What are the different possibilities? So let's just take a look. Let's move these over here. Like this, and then paste another one. 1, 2, 3. And there's actually one more. All right, so there's actually 5 pods. So take a parabola. You can actually just take this thing, really. So we could take this parabola here, and I can just move it, So we can copy that. And we can look at the different possibilities. So it could basically not cross at all. It could be tangent or just touch in one spot. It can touch in 2 spots. It can touch in 3 spots like that. Or it can touch in 4 spots. It didn't quite work, but it goes 4 different places it could touch. So 4, 3, 2. This would have to be 1 or none. So those are different possibilities. So we'll just paste it there. Paste it again in 1. Paste it again in 2. Paste it again in 3. So it's just tangent down there. Paste it again in 4, and I'll extend that out. So those are your different possibilities for a circle and a parabola. And let me put a dot where those intersections are. So there's one intersection there. This would just have 2. This one is 3, where it just comes down and touches down there. And this one will have 4, and I'll extend that out. Okay, so this one would keep going, of course, and it would go through again there and there and there and there. And it's usually symmetric. I didn't draw this, of course, too well, but you can get symmetry in these intersections. So there's 5 different possibilities. And when you're solving the system, you don't have to always graph these, but when you solve the system, the math will determine the number of solutions. So let's look at some examples what the systems look like. So let's look at this example. So solve x squared plus y minus 3 squared equal to 4, and x plus y equal to -4. And we'll review how to graph circles. That goes way back to, I forget what chapter, but it goes way back. We'll review that a little bit, but just actually briefly, why not? X minus h squared plus y minus k squared equal to r squared, where the center is hk, and of course the radius is r. It's the square root of whatever's over there. So that's a circle centered at hk. So if you have some circle, then the center will be hk. So here's your h on your x, and here's your k on your y. And then the radius, of course, is r. Okay, so we'll be using that a bit now. So to solve this, though, what we normally do is use substitution. So most of the time, put that in quotes, most of the time, use what I'll say direct substitution. So we can solve the top equation for x, and you get negative x minus 4, and then we'll take the negative x minus 4 and substitute for the y. So the y will go right there. And substitute it directly in, then we just solve for the x. So you get x squared plus, and then your y is negative x minus 4, and then minus 3, right? That's exactly where I'm substituting it, right there, for your y. And then it's that whole thing is squared, which we will have to simplify that and multiply it out. Okay, so this is equal to, let me move this over, give myself some more room. So that's x squared, and then it's going to be a plus negative x minus 7 quantities squared equal to 4. And then you have to multiply it out. Now, notice that the negative will disappear. So if you have negative x plus or minus b or something like that, and you're squaring it, you can factor out that negative 1 and it's squared. So that just becomes x plus b squared. So that always happens with that negative and you're squaring it. When you multiply it out, you'll see that that's what happens. So when you multiply this out, you get x squared. Let's move this up. And then it's going to be plus x squared. And then plus the middle term is twice the product, which is 14x. And then plus 7 times 7 is 49. And that's equal to 4. Simplify that further. Sorry, I don't know why it does that. Never did that in class, it seems. So 2x squared plus 14x plus 45 equal to 0. And what you would do next is you try to factor that thing. Try to do different combinations, and you realize it's not going to factor nicely over the integers. So you need to use something else, another method. So what we can use to solve this is use the quadratic formula. All right, so we're going to have to use a quadratic formula. You can complete the square and all that, but it's probably the easiest thing to do is quadratic formula. So write it down every time you use it. X is equal to minus b plus or minus the square root of, let me erase that, that wasn't very good. Plus or minus the square root, b squared minus 4ac all over 2a. So we substitute in our coefficients, right? A, B, and C. So our coefficients are here. So A, B, and C. And so you get negative 14 plus or minus the square root of, and then it's 14 squared minus 4 times 2 times 45 all over 2 times 2. Okay, so then you simplify that a little bit. But what you'll see that you get is you get negative 14 plus or minus, but that's the square root of, and you end up getting negative 164 over 4. So what does this tell you here? And that tells you that the solutions are imaginary. So they don't show up on the axes, right? You have a real axis and a real axis when you do this, like that. And so they're not there. So basically, there's no point of intersection between the parabola, which is this guy, or circle, this is the circle. Between that circle and this line, there's no point of intersection. Now I'm going to go ahead and graph that just to show you what it looks like. So let's do the graph because it's worth looking at. So there wasn't asked to do this. You can stop right there and just say no solution to the system. So the circle is, do HK. Let's come back up here. And we'll say H is 0, and your K is 3, and your radius is 2. So we'll do the circle. So it's 0, 1, 2, 3. 1, 2, 3. Radius of 2. 1, 2, 1, 2. All right, so we'll do a circle. Okay, close enough. So there's our circle, and then our line, and I probably should label that, huh? So that's, well, you can see there, it's 3. Okay, it's to scale, so it's working good. And then the line is x plus y equals -4. So x plus y equal to -4. So y is equal to -x minus 4. So you're down at -4, 1, 2, 3, 4, with a slope of 1. Up 1 over 1, like that. So it looks like your line goes like this. So there's your line, completely missing the, so it's -4, slope of -1, completely misses the circle. And that's what we expected, right? Because you don't get a solution, it's imaginary. So there's no solution to the system. Okay, so that's one of the concepts processes that we will do. Let's take a look at another one. So next example. Let's see, so x squared over 4 plus y squared equal to 1. Now you're not asked to graph this one. We will talk about this graph later. This is an ellipse. X squared over 4 plus y squared equal to 1. And x equal to -2y squared plus 2. Okay, so solve the system. So here's the thing on this one. You could substitute for x, because x is already solved for. But sometimes that's more difficult to do, because if you solve for x, then you're going to substitute here, and then you're going to be squaring that whole thing, which can get kind of messy. So one of the techniques we use is you solve for the square. So you can solve for the square of a variable. So we can actually solve then for x squared and substitute here instead. And it turns out that's going to be the ticket. That's going to be what we want to do. So let's do that. So we get 2y squared equal to 2 minus x for that second equation. And so y squared is equal to 2 minus x over 2. And now we can take that and substitute in for your y squared. Okay, so substitute for y squared. I don't really want to use that notation. So just say now, substitute for y squared. So you end up with x squared over 4, and then plus your y squared, so which is 2 minus x over 2, and that equals 1. And then we can solve for that. So now solve that and simplify it. So the easiest thing to do is multiply by the LCD. So multiply by the LCD on both sides. The LCD is equal to 4. So you get x squared plus 2 times 2 minus x equal to 4. So you get x squared plus 4 minus 2x equal to 4. X squared minus 2x equal to 0. Subtract those 4's and they're gone. It's annihilated. Then you solve this, factor out the x. You get x times x minus 2 equals 0. So you get your two possible solutions, x equal to 0 or x is equal to 2. Now you back substitute for your x to solve for your y squared. So now back substitute into either equation. So you have two cases. We have to be careful here because we have two cases to do. So we're going to say if x is 0, solve. So let's do that over here. Okay, so if x is equal to 0, then we have 0 squared over 4 plus y squared. That looks like equation 1 is the easiest one to solve for. Then you get y is what? It's plus or minus 1. Don't forget both cases. It's the square root property. So you have 0, 1 and 0, negative 1 so far are your two possibilities. Now, next case, we're going to say, so let's suppose x is 2. Okay, so we'll do that over here. We're going to say if x is equal to 2, I get 2 squared over 4 plus y squared is equal to 1, and I solve that. All right, so that's equivalent to 1 plus y squared equal to 1. So y squared is equal to 0, so y is just 0. So then if x is 2, we get 0. So it's just one more point. So your solution set has those three different values in it. 2, 0, and then 0 plus or minus 1. So there's three solutions. So touch the graph 3 times. And what you actually have looks like you have an ellipse and a parabola sideways that opens to the left. Okay, and we don't need to know that graph yet, but I'm going to show it to you anyway. Okay, so your solution set is 0, 1, 0, negative 1, and 2, 0. So we will talk about graphing ellipses later, and this is what it looks like. So we might as well show you now. So the ellipse is the x, where'd it go? There it is. X squared over 2. So underneath the x is 2, and underneath the y is 1. So this is x and y. It's actually centered at the origin. So 1, 2, 1, 1, 2, 1. So your ellipse is here. See if it draws an ellipse. Yeah, it did. Sometimes it doesn't work. Okay, close enough. And then your parabola actually opens let's look at our parabola. So it's x equals negative 2y squared plus 2. So you treat it kind of the same way, but it's opens along the y-axis, or I'm sorry, x-axis. So it's opening to the left, actually, and it hits those intersection points. So it's shifted to the right 2 spaces. So it's starting here at 2, and then it's going to hit 0, 1 here and here. So the graph basically does